Hello everyone, welcome to Sangam Tutorials, Cbse online classes for Ncert, Cbse 10th standard for mathematics and science. So in the previous session we have discussed regarding the riders and numericals on areas of similar triangles. So in this session also we will be going with some more riders and numericals on areas of similar triangles. So on board I have a very important question which is in your textbook as a word example. So I will present the problem in detail, right? Please look at the problem very carefully. It is a combination of a Thales theorem and also a combination of areas of similar triangles. So it's a combination of two theorems. So it's important. It may be asked in your examination for 1 mark or it may be asked for 2 marks, right? So now, in triangle ABC, XY parallel to BC. So this is triangle ABC and XY is parallel to BC, right? And XY divides the triangle into two parts of equal area. So this is the turning point of the problem, right? So it divides, that is the line XY divides the triangle into two parts of equal area. So one part is this, another part is this. So here this part and this part, they are equal, that is AXY triangle and XBCY, maybe it looks like a trapezium. So this trapezium area and this triangle area are, they have become equal. Here I am not going to mention that it is a trapezium. It has one pair of sides are parallel to each other, therefore I am going to call this as a trapezium, right? So in triangle ABC, XY parallel to BC and this line XY divides triangle ABC into two parts of equal areas. So if this is the case, find BX by AB, that is find the ratio between BX and AB. So very simple question, but it's a very interesting problem. So let us get into the solution. So now in triangle ABC, XY parallel to BC, XY is parallel to BC, very simple, it's according to the data. So now, here, this entire triangle, inside this entire triangle, we have two areas, that is triangle AXY and triangle, that is trapezium XBCY. So we have two areas, but these two areas they are equal. So XY is drawn in such a way that this area is equal to this area. So therefore, area of triangle ABC, you can write like this, area of triangle ABC is equal to twice the area of triangle AXY. We can write it here because this area is equal to this. So therefore, in triangle ABC, this area plus this area, as they are equal, so therefore we can take this area of triangle AXY as twice. That is, area of triangle ABC will be twice the area of triangle AXY. So therefore, area of triangle ABC by area of triangle AXY will be, that is 2 by 1. So this will be the condition. So when we take the ratio between area of triangle AXY and area of triangle ABC, it will be in the ratio 1:2. Or if you take the ratio between area of triangle ABC and area of triangle AXY, then the ratio will be 2:1. So this is we'll put a full stop here. We'll continue with the next thing. So here XY is parallel to BC as mentioned. So we'll select triangle ABC and triangle AXY. So in triangle ABC and triangle AXY, as XY is parallel to BC, angle ABC will be equal to angle AXY. So these two angles will be equal. So angle ABC is equal to angle AXY because they are corresponding angles. You have to write the complete thing. So and angle ACB, this angle is equal to angle AYX, this angle. So angle ACB is equal to angle AYX. So reason is corresponding angles. So therefore, in both the triangles, that is triangle ABC and triangle AXY, two pairs of corresponding angles have become equal. So according to the theorem, that is A criterion, so triangle ABC and triangle AXY are equiangular. They are equiangular. So if two triangles are equiangular, we know that according to the theorem they will be similar. So therefore triangle ABC is similar to triangle AXY. So that is AA criterion. According to AA criterion, both the triangles have become similar, right? So once the triangles they have become similar, we can take the proportionality between the corresponding sides. So we can take it here, AX by AB. We can take it like this. Therefore, AX by AB is equal to, you can take the proportionality, okay, directly take the apply the theorem 2 here. So AX by AB is equal to XY by BC is equal to AY by AC will be the proportionality, right? So now we will take the theorem. So area of triangle ABC, or first we can take AXY itself, area of triangle AXY by area of triangle ABC is equal to, for triangle AXY I am going to take side AX, so AX square by, for triangle ABC I am going to take AB, that is AB square. So you can write reason as theorem on areas of similar triangles. Right, so this will be the reason, or you can write areas of similar triangles are proportional to the squares on their corresponding sides. That can also be written. So now area of triangle AXY by area of triangle ABC I have taken. So area of triangle AXY by area of triangle ABC ratio will be that is 2 by 1. As I have taken the reciprocal of that, you can take it as 1 by 2 is equal to AX square by AB square. As this has square and this has square, so we can cancel these two squares and put a whole square for this. So when you take reciprocals on both sides, when you take square root on both sides, you are going to get square root of 1 by 2 will be equal to square root of AX by AB whole square. So square and root cancels, square root of 1 is 1, by square root of 2 is square root of 2 itself, because 2 is not a perfect square. So 1 by root 2 is equal to AX by AB we have got. But we have to find the ratio, not AX by AB, but we need BX by AB. We have to find BX by AB. So we need BX to be in the numerator and AB in the denominator itself. So therefore, subtract on both sides by 1. Subtract on both sides by 1. Okay, 1 minus 1 by root 2 is equal to 1 minus AX by AB. So by 1, it is by 1. 1 and root 2 LCM is root 2. So 1 by 1 into root 2 is root 2 minus 1 by root 2 into root 2 is 1 is equal to, okay, 1 and AB LCM is AB, okay, 1 by 1 into AB is AB minus AX by AB into AB is AB cancels, so remaining is AX. So therefore, root 2 minus 1 by root 2 is equal to AB minus AX from the figure. So from the figure, AB minus AX is BX. So instead of AB minus AX, I can write BX by AB. So what is the ratio? That is BX by AB is equal to root 2 minus 1 by root 2. So in the similar manner, you can also find out. So we already got here, that is AX by AB is equal to 1 by root 2. This is also a result actually. So this is BX by AB. So I hope you can also find out AX by BX. So do it as a homework. Find the ratio between AX and BX as a homework. So what is to be done to find out AX by BX? So AX is 1 and BX is root 2 minus 1. So AX by BX is 1 by root 2 minus 1 will be the answer for this. So do it as a homework. That is, continue this, that's all. So this is for 2 marks. This can also be used as a multiple choice for 1 mark. So therefore you have to practice this well, right? Okay, now let us get into the very important rider on areas of similar triangles. That is, prove that areas of similar triangles are proportional to the squares on their corresponding medians. Actually, instead of medians, if it was sides, then we would have called it as the theorem. So this is also true. This is the statement which follows the theorem. So as theorem is very important, this rider is also very important, which follows the theorem. So prove that areas of similar triangles are proportional to the squares on their corresponding medians. So let us go with the diagram. Very important. We have to practice this well. So diagram. So we have to draw two triangles. Okay. Right. So let us call it as triangle ABC. Let us call it as triangle DEF. Right. So these two triangles are already similar, right? So prove that areas of similar triangles, already these two triangles are similar, are proportional to the squares on their corresponding medians. So we have to draw 2 medians here. So let us draw a median. So this is the median. So let us call it as AP, and let us call this median as DQ. Right. So here a median is a line which divides the base into 2 equal parts. So BP will be equal to CQ and EQ will be equal to QF. So this is the diagram. So we'll write the data. The description of the diagram is called as the data. So triangle ABC is similar to triangle DEF because already triangles are similar. So AP and DQ are medians. AP and DQ are medians. Okay. So therefore BP is equal to PC and EQ will be equal to QF. So you have to prove that. So what is to be proved? Areas of similar triangles. The ratio between the areas of similar triangles are proportional to the squares on their corresponding medians. So that is area of triangle ABC by area of triangle DEF will be equal to AP square by DQ square. AP square by DQ square. This is what we have to prove. Right. So as this data is sufficient, we can directly enter into the proof. Right. So this is the proof for this. You have to practice this well. So one homework I am giving you at this point. So prove that areas of similar triangles are proportional to the squares on their corresponding altitudes. Instead of medians, prove that areas of similar triangles are proportional to the squares on their corresponding altitudes. This was also a question asked in one of the examinations in Karnataka state syllabus in the previous years, right? So okay. So we'll take up with the similarity. So ABC is similar to triangle DEF. So triangle ABC is similar to triangle DEF. Okay, according to the data. So as both the triangles are already similar, we can directly apply the theorem on areas of similar triangles. So therefore, area of triangle ABC by area of triangle DEF will be equal to AB square by DE square. I hope you can write this. AB square by DE square. So reason is theorem on areas of similar triangles. Theorem on areas of similar triangles. So this is the thing. So now, as both the triangles are similar to each other, right, we will take the proportionality AB by DE. AB by DE is equal to BC by EF. BC by EF. So, therefore, AB by DE is equal to, this BC can also be written as 2BP or 2PC because P is the midpoint of BC. So, therefore, instead of BC, we can write 2BP or 2PC. So, here in this case, instead of EF, as Q is the midpoint of EF, instead of EF, we can write 2EQ or 2QF. So, instead of BC, I am going to write 2BP by, instead of EF, I am going to write 2EQ. So 2 and 2 gets cancelled. So remaining thing is AB by DE is equal to BP by EQ. So this is the result we have got. Take it as equation 1. Okay. Now select these two triangles. In triangle ABP and triangle DEQ. These two triangles. So in triangle ABP and triangle DEQ. Triangle ABP and triangle DEQ. AB by BP, we can write this ratio, numerator by numerator, denominator by denominator. So that is AB by DE is equal to BP by EQ. It is proved. What we have proved this, but we are going to take it like this: AB by BP is equal to, here DE by EQ, that is DE by EQ. This is true, and along with that, angle B is equal to angle E, because triangle ABC is already similar to triangle DEF. If two triangles are similar, they will be equiangular. If they are equiangular, that means their corresponding angles are equal. So therefore, angle B is equal to angle E. So angle B is equal to angle E. So therefore, two sides and an included angle of one triangle are correspondingly equal to the two sides and the included angle of the other triangle. Then both the triangles are similar to each other according to SAS similarity criterion. So therefore, triangle ABP is similar to triangle DEQ. So that is according to SAS similarity criterion. Okay. So these two triangles are now become similar. That is these two triangles. Now we can take the corresponding sides proportionality. That is BP by EQ will be equal to AP by DQ. So therefore, BP by EQ is equal to AP by DQ. Take it as equation 2. Now compare equation 1 and 2. So here AB by DE is equal to BP by EQ, and BP by EQ is equal to AP by DQ. That is AP by DQ. Okay. So therefore, AB by DE will be equal to AP by DQ. So therefore, from 1 and 2, equations 1 and 2, AB by DE is equal to AP by DQ. So as now we have proved that AB by DE is equal to AP by DQ, in this, inside this, instead of AB by DE, we can substitute AP by DQ. So therefore, area of triangle ABC by area of triangle DEF will be equal to, instead of AB by DE, I am going to write AP by DQ. It becomes AP square by DQ square. So that is what we had to prove, right? So therefore, hence it is proved, right? So very important problem. You have to practice this very well. So here I have changed the question for homework. Prove that areas of similar triangles are proportional to the squares on their corresponding, instead of medians, you have to prove that it is altitudes, right? So you have to separate the diagram. When you draw a line from the vertex to the base, you have to put a right angle here. Here also you have to put a right angle. Then proceed with the proof. Right? Okay. Okay. Let us get into the third problem. Very important again. It's a rider. So prove that area of an equilateral triangle described on one side of a square. So just imagine a square. You have to imagine a square here. So let us put up a square. So let this be the square. Right. So let us name this A, B, C, D is a square. Right. So in a square we know that all the four sides are equal. Right. So area of an equilateral triangle described on one side of a square. Okay. So what they have done is, on this square they have selected a side, and on that side they have constructed an equilateral triangle. So this is the equilateral triangle. Okay. So this is square ABCD. All the four sides are equal. We know that. Okay. Now, see, this is the equilateral triangle which is described. So here, the length of the side of the square is equal to the length of the side of the triangle. So then only it is going to become an equilateral triangle, right? So now the area of this equilateral triangle, which is described on one side of a square, is equal to half the area of equilateral triangle described on one of its diagonals. Okay, we will draw the diagonal now. So this is the diagonal. Let AC be the diagonal. You can also take BD as the diagonal, no problem. So on this diagonal they have constructed an equilateral triangle. Okay, they have constructed an equilateral triangle here. So this is the equilateral triangle. So now we will name this. So let APD be one of this triangle and AQC be another triangle, right? So this is the equilateral triangle described on the diagonal of the square, and this is the equilateral triangle described on the side of the square. So now here, as we have taken this as an equilateral triangle, the length of AC will be equal to length of CQ, and the length of AC will be equal to length of AQ. So that is, this length will be equal to this, will be equal to this. But we do not know any one side of this equilateral triangle, or we do not know this, or we do not know the side of a square. So at this point we will have to guess. Let the side of the square be A unit something, then we will go with the remaining things. Okay, let us get into the solution. Let the side of square be, A units. Let the side of the square be A units. Okay, so this will be A units, this will be A units, this will be A units, and this will be A units. Now, if you consider triangle ABC here, it is going to become a right angle triangle. So it's a right angle triangle here. So because in a square all the four angles will be equal to 90 degrees, and among the four angles I have taken one angle here. So therefore angle ABC will be equal to 90 degrees. So in triangle ABC, angle B is equal to 90 degrees. So by applying Pythagoras theorem, right, for this right angle triangle, we will find out the length of AC. So AC square is equal to AB square plus BC square. AB square plus BC square. So AC square is equal to A whole square plus A whole square, because each side is A units. So AC square is equal to A square plus A square is 2A square. So when we take square root on both sides, so we get AC square is square root is equal to square root of 2A square. So square and root cancels. So AC is equal to square. A square is a perfect square, so it becomes A, and 2 is not a perfect square, therefore the root symbol remains for that. So it becomes A root 2. So the length of AC, that is the diagonal, is A root 2. Right. So if this is A root 2, then this will be A root 2 because it's an equilateral triangle, and this will also be A root 2. Right. So this is how it goes. So here we have to prove that the area of this triangle is half the area of this triangle. That is, area of triangle DPA is half the area of triangle AQC. That is what you have to prove. So is equal to half the area of equilateral triangle described on one of its diagonals. So right. Now, before taking the similarity criterion, first we have to prove both the triangles are similar to each other. That is, triangle PAD and triangle QAC are similar to each other. Right. So in triangle PAD and triangle QAC, angle PAD is equal to angle QAC, this angle. So angle PAD is equal to angle QAC because it is 60 degrees. Each equilateral triangle measures 60 degrees, all the three angles. And angle PDA, this angle, is equal to angle QCA, this angle. So angle PDA is equal to angle QCA. So it is again 60 degrees. So now, in these two triangles, two pairs of corresponding angles have become equal. So therefore, according to AA criterion, both the triangles are similar to each other. So therefore, triangle PAD is similar to triangle QAC according to AA criterion. So now we can take the that is ratio between the two triangles, that is ratio between the areas of two triangles here. So therefore, area of triangle PAD by this one, area of triangle PAD by area of triangle QAC. So area of triangle QAC is equal to, for area of triangle PAD we will take AD as the AD as the one of the side, and for AD, AC is the corresponding side for triangle QAC. So that becomes AD square by AC square. So reason is theorem on areas of similar triangles. Theorem on areas of similar triangles. Okay. So area of triangle PAD by area of triangle QAC is equal to, so we know that the length of AD is A. So AD is A, but AD has square for that. So therefore it is A square by AC. So the length of AC is A root 2. So instead of AC I can write A root 2, but it has square there. So therefore I am going to put up whole square for that. So area of triangle PAD by area of triangle QAC is equal to A square, A whole square is A square, this square applies for A, it is A square into square and root 2 are there, square and root 2 cancels, that is 2. So A square and A square cancels. So area of triangle PAD by area of triangle QAC is equal to 1 by 2. So when you go for cross multiplication, therefore area of triangle PAD, that is 2 into something like this, 2 into area of triangle PAD is equal to area of triangle QAC. So when you put 2 to the denominator, so area of triangle PAD is half into area of triangle QAC. So this is what we have to prove, that is area of the triangle which is described on one side of a square is half the area of the triangle which is described on the diagonal of the square. So this is how it goes. Very important problem. You have to practice this. Now let us get into the fourth problem. Very important. ABC and BDE are two equilateral triangles such that D is the midpoint of BC. So let us draw the diagram. So in the textbook it is given as a multiple choice. This problem is given as a multiple choice. So let this problem be asked for multiple choice, as also it can be asked for 2 marks. So I am considering this problem as a 2 marks problem, and then I am going with the procedure. So if it is asked for 1 mark, you directly take the result and you can go with the answer. So triangle ABC and BDE. ABC and BDE are two equilateral triangles. So equilateral triangles in the sense all 3 sides are equal. Hence the 3 angles will be equal to 60 degrees. Okay. Such that D is the midpoint of BC. So let us take this as triangle ABC and D is the midpoint of BC. So therefore BD will be equal to DC. Right. D is the midpoint of BC. Find the ratio of areas of triangle ABC, and triangle BDE. Somewhere we have to go with point E here. We have to join this. So this is BDE. So BD length will be equal to ED and ED length will be equal to BE, because this is an equilateral triangle and this is an equilateral triangle. That is, triangle ABC is equilateral, BDE is also equilateral. So now we have to find the ratio between triangle ABC and triangle BDE, which are both equilateral. Okay, let us get into the solution. Right. So here it is not mentioned that both the triangles are similar. Just he has mentioned that both the triangles are equiangular, that is equilateral. So I can go with the result like this. Equilateral triangles are equiangular. Equilateral triangles are equiangular. So therefore, if 2 triangles are equiangular, then they are similar. So therefore, triangle ABC and triangle BDE are equiangular and hence similar. So this concept applies only when the 2 triangles are equilateral, only, not for other triangles. Therefore, triangle ABC is similar to triangle BDE. Okay. So therefore, area of triangle. Okay, let us do one thing. As we do not know the sides of this, let us take. Let the sides of triangle ABC be A units. Let sides of triangle ABC be A units. Okay. So this is A unit, and this will be A units. So as D is the midpoint of BC, so BD will be equal to A by 2. So as BD is equal to ED, so ED will be A by 2. As ED is equal to BD is equal to BE, so therefore BE will be A by 2. So let sides of triangle ABC be A units. So therefore BE is equal to BD is equal to ED. BD is equal to BE is equal to ED is equal to A by 2 units. So now we will take the ratio. So area of triangle ABC by area of triangle BDE. Find the ratio of areas of triangle ABC and BDE. So therefore I have taken ABC and BDE is equal to AB for triangle ABC and BE for triangle BDE. So as since all the 3 sides are equal, you can take any ratio, any corresponding side. So AB by BD I will take, or you can take AB by BE better. So AB square by BE square. AB square by BE square. So reason is theorem on areas of similar triangles. Theorem on areas of similar triangles. So this is the thing. So now area of triangle ABC by area of triangle BDE is equal to AB, we have taken it as A square, by BE is A by 2, so that becomes A by 2 whole square. So we will expand that, we will apply the square. So area of triangle ABC by area of triangle BDE is equal to A square by A by 2 whole square is there, so it becomes A square by 4. Let us take reciprocal for this. So it becomes A square by 1 into 4 by A square. So A square and A square cancels. So remaining is 4 by 1. So area of triangle ABC by area of triangle BDE is equal to 4 by 1. So the ratio, what it is asked between, find the ratio of areas of triangle ABC is to triangle BDE. So therefore area of triangle ABC is to area of triangle BDE is equal to 4 is to 1. So this is the answer. Right? It may be asked for 1 mark, or it may be the same question can be asked for 2 marks also. Right? So in this session, I hope you enjoyed all the 4 problems, which are very, very important. All the 4 writers, please practice that. Homework, prove that the areas of similar triangles are proportional to the squares on their corresponding altitudes. That is the homework for you. You have to prove that. So let me see how many of you are going to send me the answers tomorrow. I will be waiting with a lot of eagerness. So in tomorrow's session, it's going to be a very big session, very important session, because I am going to prove the most important theorem in the entire syllabus of triangles, that is Pythagoras Theorem. So a little bit of theory is involved in that, a little bit of history is involved in that. So I will discuss all the things, then I will go with the proof for Pythagoras Theorem. So don't miss tomorrow's session. Until that, stay home, stay safe, and keep learning. Thank you.